So today we will discuss material requirement planning. So it is a computer-based inventory system where production manager used to assist the production manager to place orders, schedule the items from dependent demands. And those dependent demands are component, part, and raw materials. This MRP is designed to answer three questions, which are what is needed, how much is needed, and when it is needed. So it started in finished good that is converted in the schedule from requirements for component parts and raw materials needed to produce in the final product within an established schedule. To understand more MRP and how MRP works, let's look on the PowerPoint presentation or the example in the PowerPoint presentation. You can find there an example of MRP logic and product structure tree. So we will see here a product structure tree for assembly A to F. So in the right side, there's a lead times. Lead times means how long does the materials will arrive, and also a total unit demand. In day 10, we have a 50 units in assembly A. In day 8, we have a 20 units in assembly B. Spares. Spares means it is a replacement of damaged items. In day 6, we have a 50 units in assembly D. Spares again. So in the next slides, we can see another table for assembly A. There's a required cell and order placement cell. Because we have a total demand of 50 units in assembly A, in day 10, we will put it is required. It will put in the required row. So we will put the 50 units in the day 10. And why it is in the day 9? Because we have a lead times of 1 day. So if we will less that day 10 and day 1 of lead times, of course it will result in 9. So we will put it in the day 9. So as well as in the assembly B to F. So we will go to another table. Finally, the repeating process for all components. So in order to release A, B, and C, let's look on the structure tree. B, as you can see, B and C is connected to assembly A, which means B is equals to 4A and C is equals to 2A. And that's why, as we can see in the table, the required row for assembly B and C is connected to the order placement or at the day of order placement of assembly B in day 9. So where does the required row of 200 in assembly B came from? It came from 4 times 50 of us 4 times 50. 50, why 50? Because just like what I said, B is equals to 4A. 4 times 50 is equals to 200. So the required row would be put in the day 9 for assembly B. So because we have a lead times of 2, of course, 9 minus 2 is equals to 7. So we will put it in the 7 days of order placement of assembly B. So where does 20 came from? It came from the total unit demanded a while ago in assembly B, which means the spares. So it is in day 8, so we will put it in day 8 in required row in assembly B. And because we have a lead times of 2 days, we will list 8 in 2 days, so we will come up with the answer of 6. So we will put it in the day 6. So as well as in assembly C, as you can see, we have 100 required units and order placement of 100 units because we have a lead times of 1 day. So where does 100 came from? It came from 2 times 50. 50 is came from assembly A. So next is assembly D. As we can see in structure 3, D is connected to B and D is also connected in C. In order to release D is equals to 2B and D is equals to 3C. So let's look first on the assembly B. As we can see in order placement in assembly B, we have a 200 units in day 7. So D is equals to 2B. So let's multiply the 2 in 200, which will result in 400. So 400, we will put it in the required row of assembly D. So as we can see, there's have a 400 here. So next is the D is equals to 3C. Let's look on the order placement of assembly C. We have 100 in day 8. So we will multiply the 3 in 100. 3 times 100 is 300. So we will put it in the required row for assembly D. So we have 55 here. So where does it came from? It came from 40 plus 15 spares. Because we have a lead time of 3 days, we will, of course, we will less the day 8. So in order placement of assembly B, we will put the 300 in day 5 as well, the 455. So next is in assembly C. As we can, assembly E. So let's look at again in the structure 3. E is equals to 1B. So required, let's look B. So it is connected in assembly B. So let's look again on order placement of assembly B. We have a 200 in day 7 again. So we will multiply it in 1 because E is equals to 1B. So we will put the result of 1 times 200 is 200. So we will put the 200 in required row for assembly E. And because we have a lead time of 4 days, we will less the day 7 into 4, so that the order placement would be in day 3. So where does 20 came from? It came from the total unit demand a while ago. It is also a spare in assembly E. That's how MRT worksheet works.
And topic 1 is discuss ko is all about MPS. MPS stands for Master Production Schedule, and by that, it is a time-based plan specifying how many and when the firm plans to build each end time. Using the MPS, it helps to avoid a shortage and also a deficient allocation for the resources. And also it allows a business to consolidate a planned parts, and by that, they forecast for any level of BOM or bill of materials for any type of a part. Next is a types of a time fences. So there are 3 types of time fences. First is a frozen, second is a moderately firm, and third is a flexible. First is a frozen. Frozen is a no schedule allowed to change on a production. Ibig sabihin po, parang pag nag-produce na ng isang product, parang mga first week to second week hanggang fourth week, hindi pwedeng magbago ang schedule doon kasi parang minimit muna nila yung pagkuha ng kung gaano kadami ang kanilang nasa plano or kung quota nila do sa paggawa ng production. Next naman po is a moderately firms na kung saan it is have a specific changes on its firm, and it's allowed to a product that is as well as the part of a product to change is available. So parang pumapasok po dito na kung saan mga pagkatapos po ng frozen, pag magano na po no sa production, sa pag-schedule, parang dito na po nakapaloob ng or may mga kunyari babaguhin konti, like a production for a bottle, iaano na po dito yung parang may changes na kauntian, pero dapat yung changes na iyong idadagdag or iaano ay available yung parts na yon. Next naman po is a flexible. Flexible is a significant variation allowed as long as a overall capacity requirement remains at the same level. Example po dito ay parang any kind of changes, pwede po siya. Katulad na lang kunyari sa production ng bote, kunyari may gusto kang palitan na design or hugis nun, pwede mo siyang ma-change kasi gawa ng parang naiisip mo kung anong mas babagay or kung ano angkop na design ng bote. Example of time fences, meron pong 3 column. Una po dito ay ang frozen, pangalawa ay ang moderately firms, pangatlo po ay flexible. Makikita po natin sa gilid po ng frozen ay ang kanyang capacity. Ang pinakang nasa ilalim po nitong 3 ay ang week, kung gaano kahaba yung schedule. Una po makikita po natin sa frozen, parang dito po yung may pagbabago pero napakakunti, parang tinatawag pong itong emergency changes. Pangalawa po ay yung moderately firms na kung saan merong specific changes na tinatawag, parang ito po yung tinatawag na trade-offs. Dito po sa dalawa, parang ito po yung pinakang firm customer orders or yung parang actual orders po nung customer sa inyo. And then, dun po sa pangatlo na po ay flexible na kung saan makikita po natin doon sa pagtagal po ng week, pagbaba din po ng capacity kasi gawa ng nangyayari na po doon ang iba't ibang changes. By that, the next topic is a material requirements planning system. And also it based on the MPS, and that creates a schedule identifying the specific parts and materials required to produce an end item. Dito po parang kino-compute na nila or inaalam na nila kung ano ang kanilang mga gagamitin sa paggawa ng produkto. And next is a determine the exact unit needed. Dito pa parang nade-determine na nila dun sa kung gaano kadaming mga materials at saka mga specific parts ang kanilang nakuha, kung gaano kadami ang kanilang maproproduce na unit. And the lastly is a determines the date when the orders for those materials should be released based on the lead times. Parang dito po, nadidetermine na nila pagkatapos silang buo yung product or maano yung pinakang target na unit nila, madedetermine na nila kung kailan nila i-deliver yung orders na ginawa nila.
A bill of materials. Break down every components needed to manufacture your product, from raw materials to assembles and sub-assembles to quantity of each component. Like what did you get in a new dresser? And the first thing in the instruction is what is in the box, or how a recipe begins with the things you will need. A build of materials can be single level or multi-level. And single level build of materials for, say, a wheelbarrow, with a wheelbarrow at the top, underneath the wheel, legs, handle, and the bucket. The multi-level build of materials offer greater detail and more levels. So the wheel might needed an axle, spacer, and a bracket axle. The legs needed with the bolts and braces. Handles needed wheel cutter and spacer. And the packet required different kinds of bolts. It would also outline the quantity, cost, product code, description, and other part specification. A build of materials serves as a foundation of production planning system and provides the data for other business process. It helps companies plan material purchase, estimate cost, control inventory, track and plan material requirements, and reduce waste. The next is the inventory record file. So we have the two ways to record the inventory. First is each inventory items carried as separate files according to the time bucket. Second is paging that identify each parent item that created demands. We have the different kinds of reports that to be considered as the primary MRP. First is the planned orders that release at a future time. Next is the order release notice that execute planned orders. Next is the changes in due date that we open orders due to the scheduling. Next is the cancellation or suspension. This is to open orders due to suspension or cancellation orders of the master production schedule. And last is the inventory status data. So we have the different kinds of reports to be considered as secondary MRP. First is the planning reports. For example, forecasting inventory requirements over a period of time. Second is the performance report. It is used to determine agreement between actual and program usage and cost. And last is the exception reports. It is used to point out serious discrepancies such as late or overdue orders. Next, MRP terminologies. So first is the gross requirements. It is the total expected demand. Second is the scheduled receipts. It is an open orders scheduled to arrive. Third is the projected on hand. It is the expected inventory on hand at the beginning of each period of time.
Ang ipapaliwanag ko ay MRP example. So, ayun. Meron tayong item na si item X, item A, item B, item C, and item D. Meron silang on hand na 50, 75, 25, 10 at 20. Ang lead time ay 2, 3, 1, 2, and 2. Yun ay sa weeks. Tapos, requirements include is 95 units for item X on week 10.
Yan, kasunod ay ito, si production 3. Si item X, under niya si item A and B. Then under ng item A is si item C. Under ng item B is item C and item D.
Kasunod ay ito, master schedule. Ito na yung kabuuang schedule nung sa lahat ng item. Ayan, nandyan hanggang si item D. Kaunahang item sa master schedule ay ang item X. So item X yan from week 1 to 10. May lead time na 2. So gross requirements niya 95. Then projected available balance yung kanyang on hand 50. Then net requirements 45. Nakuha siya dahil yung gross requirements na 95 less projected available balance or on hand na 50. So 45. Then planned order receipts same as net requirements 45. Then planner order release 45. May siya, lead time na 2. So si planner order release ay nakalagay siya sa week 8 kasi week 10 minus 2 is 8. Next ay item A. So ayan yung yung umpisa ng production 3. It takes 2 A's for each X. So say item A may lead time na 3 weeks. May on hand na 75. So gross requirements niya 90. Paano nakuha? Yung planner order release na 45 ni item X times 2 90. So projected available balance 75. Yun na yung kanyang on hand. Net requirements is 15. Katulad lang din nung una. Gross requirements na 90 less projected available balance na 75, so 15. Planned order receipt same as net requirements. Planner order release siya ay nasa week 5 kasi week 8 less 3 is 5. Next is si item B. So it takes 1B for each X. Meron siyang lead time na 1, on hand na 25. So gross requirements niya is 45 kasi yung planner order release ni item X na 45 times 1. Then projected available balance 25 yung on hand niya. Then net requirements is 20 kasi nga 45 times 20 minus 25. So planned order receipts 20. Same as planner order release 20 din. May lead time siyang 1, so from 8 weeks to 7th week. Next is item C. So under siya ni item A. It takes 3 C's for each A. So meron siyang lead time na 2, on hand na 10. Gross requirements niya 45 kasi yung planner order release ni item A na 15 times 3. So projected available balance na yung kanyang on hand na 10. Then net requirements 35. Gross requirements na 45 minus 10. Then planned order receipts 35. Planner order release 35. Nasa week 3 kasi may lead time siyang 2. So 5 minus 2 is 3. Next is item C pa rin. Under na, yung kanina ay under ni item A. Ito naman ay under ni item B. So it takes 2 C's for each B. Lead time 2 weeks, on hand ay 10. Gross requirements niya is 40 kasi yung planner order release na 20 ni item B times 2. Tapos projected available balance niya yung on hand na 10. So hindi siya umabot sa ano kasi hanggang week 5 lang siya. Hanggang week 5 lang ang ang on hand. So net requirements is 40 dahil nga hanggang week 5 lang yung on hand, wala kang ileles na on hand. So 40 pa rin siya. Planned order receipts 40, same lang. Then planner order release ay 40, same lang. Then lead time na 2, so from week 7 to week 5. Last item is si item D. Under pa rin siya ni B. So it takes 5 Ds for each B. May lead time siyang 2, may on hand na 20. Gross requirements is 100. Yung planner order release ni item B na 20 times 5. Then projected available balance yung 20 na on hand. Net requirements is 80 kasi yung 100 na gross requirements less 20 na on hand. So 100 minus 20 is 80. Planned order receipts same as net requirements 80. Then planner order release 80. Siya ay nasa week 5 kasi nga ay may lead time siya na 2 weeks. So from 7th week or week 7 to week 5.
Good day, this is Isis Camille Cambao, and in this reporting, there are 3 topics assigned to me. First is the closed loop MRP, second is the MRP2, and the third is the lot sizing in MRP system. So now, let's start. Closed loop manufacturing resource planning, or closed loop MRP, is a software system companies use for production planning and inventory control. This system is regulated by feedback. Since it's a closed loop, it is regulated by a feedback, and these feedbacks are used to continuously check and adjust the system. As we can see in the picture of closed loop MRP, the top box is where the production planning, mastery production scheduling, materials requirement planning, and capacity requirements planning. So it's all about the plan. And able to do this, the second option is to ask this if it's realistic or not. If it's not realistic, it is needed to go back to the planning. That's why there is an arrow to go back in planning. And then, if it's realistic, it can be executed. Just like in the box on the bottom. Execute capacity plans and material plans. And, of course, the main feature of a closed loop system is the feedback. So, the feedbacks are used to know how the system performs and what are needed to improve or change. MRP2 is an integrated information system used by businesses. Of course, MRP2 or Manufacturing Resource Planning 2 is evolved from MRP system by including the integration of additional data such as employee and financial needs. As we can see in the PowerPoint above, the goal of MRP are to plan. The goals of MRP are to plan and monitor all resources of manufacturing firm or closed loop, such as manufacturing, marketing, finance, and engineering. Also to stimulate the manufacturing. Lot sizing in MRP system. Lot sizing is determining the amount of an item that needs to be manufactured. In short, lot sizing means batching of items. So there are 4 methods of lot sizing that is mentioned in this report. First is the lot for lot or L4L. It is also called the discrete order quantity or DOQ, wherein the net requirements occurring for each period are the quantity of order. It is often used for expensive items and items with low demand. In short, it is fixed, sakto. So what you input is what you get. So So that's it. The second one is the economic order quantity, or EOQ. The EOQ for each item is calculated in advance and entered to the item as the EOQ value. So it's calculated in advance. So just like L4L, it is fixed. It is sakto. What you input is what you get. And the third one is the least total cost, or LTC. It calculates the order quantity by comparing the carrying cost and the ordering cost for various lot size, and selects the lot in which these are most nearly equal. Its goal is to minimize the total cost. And the last one is the least unit cost, or LUC. And its goal is to minimize the average unit cost per unit. Unlike the least total cost, it minimizes the average unit cost. It means per unit, not the total. So at the last part of this presentation, as we can see, there is a question. Which are to use? And the answer must be the one that is least costly. And this method depends, for me, this method depends on what type of item you're going to produce. Try them all and determine which is least costly. So that's it. Thanks for listening.